Hey everyone, welcome to Physmatica. Let's read the problem. The problem states a right triangle has both parameter and area of 30. Find the sine lengths of the triangle. So if you look at this right triangle, the problem states that a plus b plus c is 30 and the area is also 30 and it wants us to find A, B, and C. And there is a lot of ways you can solve the problem. First of all, let's write the Pythagorean theory because definitely we're going to use it. One way you can solve it is simply from here, for example, you can find C, write it based on C, and then you can substitute it in the Pythagorean theory and you can approach it and solve it. But another way and an easier way would be that using just identities. The way that works is like this. So let's just take both sides of the parameter to the power of 2. So we have a plus b plus c to the power of 2 equals 30 to the power of 2. Okay. From here we can say that a to the power of 2 plus b to the power of 2 plus c to the power of 2 plus, and we know that we can write this in this way, BC plus AC. If you don't know this identity, it's a very useful identity. When you have three terms and you can just take them to the power of 2, you will have very similar to the double type, a plus b to the power of 2. You just have a few more expressions there. And for this one, we can just simply multiply both sides by 2. So from here, we can simply conclude that AB equals 60. So this is going to be very handy. Now take a look at this one. What do we have here? We have a2 plus b2 plus c2 plus 2ab, and we have ab here, bc plus ac, and all of it equals 30 to the power of 2. Okay, so now let's just write it again. I can say that from here I can see a2 plus b2 is equal c2. So what I can do is to just simply say that this is c2, right? Having that, and if I just substitute everything there, I can write this as C2 plus C2 plus 2AB plus 2. Then what I did, because I have AB, I just take this out because this is going to eventually just become a number. And from here, if I just factor 1C, I'm going to get B plus A, everything again 30 to the power of 2. So that's what I have right now. And if I continue writing, I'm going to get 2c2 plus, we know that ab equals 60 from here. So it's going to be plus 120 plus 2. Then we have c, b plus a equals 900. Now I can continuously write this 2c2 plus, then I have this expression, and what I'm gonna do right now is to just write this to c b plus a equals 900 minus 120. Now let's take a look at this part. B plus a. If you just simply look what we have here, we have that if I bring this down, we had that a plus b plus c equals 30, right? Given by the problem. Now let's see how we can write this so we can b plus a. We can clearly see that we can write a plus b equals 30 minus c. So we can just say that this is 30 minus c. What happens if we substitute this? If we substitute what we have here, we're going to get, let me write it with white color. It's gonna be 2c2 plus, we still have this 2 here and we have a c here, so we are multiplying 2. Then we have this c that is being multiplied in this, so it's gonna be 30c minus c2 equals, and this is gonna be 780, right? So now if we solve this, we're gonna get 2c2 plus 60c minus 2c2 equals 780. And as we can see, these two gonna cancel each other out. And from here, c is going to be 780 over 60, which is gonna be 13, correct? Yes. So that's C, and we found C. Perfect. Now let's continue for the rest of the problem. How are we gonna start again? So we have C. Let's start by this again. So we have C, and as we know, A plus B plus C equals 30. And we have C now, so we can just simply conclude that A plus B equals 30 minus 13, right? Right. And from here, we can just simply say that A plus B equals 17. We also had that A plus B. Again, from here, we concluded that A plus B equals 60. So what do we have now? We have addition of the roots and we have multiplication of the roots. We can simply write this as x2 minus 17x plus 60 equals 0. And we're going to just go and solve this. Let's simply just take the delta from here. We're going to have 17 plus or minus square root of 17 to the power of 2 minus 460 over 2. What is going to be? It's going to be 17 plus or minus a square root of 17 to the power of 2 is going to be 289. This is going to be, so it's going to be 289 minus 240 over 2. This is gonna be 17 plus or minus, this is 49, right? So the square root of it's going to be 7 over 2. And from here we can conclude that our x is, one root of this is going to be 24 over 2, which is gonna be 12. And the other x going to be 5. So having all of this with each other, we can completely see and clearly see that we have 5, 12, and 13 as the side of the problem. So if we again take a look at the problem, we can see that the choice A is the correct choice. It's a very interesting problem, and the good thing about it is that you have multiple ways to solve it. Now, as a challenge, try to solve it in another way. Whatever you're going to use is probably going to be a bit longer, especially if you're just going to use it by pure substitution from the start, but you're going to have to get to the same solution. And as you can see, it's a very interesting problem. I hope you liked it. Thank you for watching.